Please welcome to the stage Glen Meyerowitz.
Good morning. It's great to be here. As the voice just said, my name is Glen Meyerowitz. I'm the founder and CEO of Clarity Technology, and I am so excited to be here this morning to get to chat with everyone at the second Global DAC Conference. Thanks to Jason, Nick, and everyone at the DAC Coalition for putting this on. And of course, thanks to everyone who's here. Let's see if I can move the slides. Fantastic. I am excited to chat with y'all about what our team is working on in Southern Nevada, Project Juniper, the home to what will be our first technical and commercial DAC pilot. We heard from Nick, Will, and others about the transition to direct air capture's show me moment, and that's just what I'm here to chat about. Project Juniper is our first direct air capture and, important to note, XC2 mineralization project with a nameplate capacity of 100 tons of CO2 capture and mineralization per year. And we expect this will be online and delivering credits this year in 2025. This project has taken a village to get going. We have a phenomenal team of project partners, many of whom are here in this room. And I appreciate, of course, the support of the entire DAC ecosystem, without which we would not be able to accomplish what we are doing. I want to start off by sharing some high-level info on our process. So Clarity uses an alkali carbonate sorbent. This sorbent is reactive with CO2 and H2O to convert from a carbonate to a bicarbonate during our adsorption process. During our desorption process, we apply heat. I love these GIFs that we made. We apply some heat, which will regenerate the sorbent at low temperatures, releasing that CO2 and H2O. And then we can collect low concentrations, low pressures of gas in our systems before we can utilize them. This is the least exciting information that I'm going to share. I'd be more than happy to talk with anyone who wants to learn more about our process and materials at any point later today, so please come find me. But again, there's dozens of DAC companies here. We are all developing similar processes. These are commodities at the end of the day. So what is it that I want to talk about? Really, our development process that led to Project Juniper. So as I said, Clarity was founded in 2022. In 2023, our team was busy in the lab testing composite sorbent material samples. We were making about 5 new samples per day, 30 per week, and we tested hundreds and hundreds of different combinations to land on the Generation 1 material that we have in our system now. That led to our first small pilot 1-ton per year reactor in Los Angeles that was critical to validating key parts of material performance, system performance, and the engineered process. And that is what has led to the development of Project Juniper. Here you can see one of 8 sorbent cartridge modules that's part of Project Juniper's 100-ton per year system. Overall, during this time, our direct air capture system was going well. We were collecting good data, seeing good results between labs and models. Our techno-economics were looking strong, but the question came up again and again, and a question that I've talked with so many people in this room about: what do we do with the CO2 that we capture from this pilot plant? Has anyone else had this question? Anyone? Right, so do we store it? Can we use it? Do we vent it? Over the last many years, for me and for others, it feels as if the goalposts around direct air capture pilots have changed, and the cost benefits of doing something versus venting that CO2 have changed. In conversations with partners, buyers, investors, project financiers, and others, it became clear that we needed to start to do something with the CO2 from this. This is a non-exhaustive list of what we were looking at, and again, I'm sure it lines up with how everyone else in this room thinks about this. I started to reach out to folks, Class 6 well developers across the US, to see whether we could, how much money can I pay you to take my CO2? They could not hit our timelines. Maybe they would be online in 2026. Maybe they would be in line in 2027. They are very expensive for the small volumes of CO2 that we want. If we can't co-locate with you, then we have to transport liquefied CO2 via trailer, rail to that site. Some of them wouldn't even talk to us because of the potential water and oxygen impurities in our systems, and of course, regulatory, project, timeline, political uncertainty with geologic injection. We've talked with e-fuels companies and folks in the food and beverage industry. I know some folks have had some initial success in small-scale pilots, which is fantastic. We've run into challenges about purity requirements from them, potential contamination of what's in our CO2 streams, and then mismatch of TRL, as that can lead to general mismatch of project risk. And I'm sure that every direct air capture technology and project developer here has talked to at least one of the low-carbon concrete companies. And most of us have probably done small demos with them. This is from us in December 2023, when we worked with Carbon Built to do a small demo to sequester grams of carbon dioxide at their facility, also in Los Angeles, near where we are. So we brought a small test module to their shop, and we were able to demonstrate an integrated test. An amazing milestone, not a pathway forward for deployable, scalable projects that could deliver real credits. So what was the issue that we ran into, right? As we started to engage more seriously with these partners, there were challenges to integrating with each one of them. They all have their own technical risks. And then we come to them and say, we have this unproven technology that we think is really important. Can you take on additional project and technical risk? And they say, no. They also have, we heard about the 150 DAC companies that exist. Every single one of us is knocking on these few companies' doors and saying, can you take my CO2, my CO2, my CO2? It's hard for them to choose. We are not extremely differentiated in terms of how we present what we're doing. And it's hard for them to do that. And then I think the worst and most challenging part is many of these companies have signed early deals or partnerships with DAC companies in 2022, 2023. And unfortunately, we have failed to deliver on what we have promised. So many of these companies look at DAC and say, we were not able to do what we needed, we overpromised and underdelivered, and that gives increased pause when we go and try to make new partnerships. So that led us to the challenging realization, right? We needed to do something with the CO2 that we capture, but what do we do with it? So it led us to the singular solution that we as Clarity Technology need to develop our own XC2 mineralization process so that we can sequester the CO2 that we generate. So I'm excited to share some of the first details from Project Juniper. This is our project site in southern Nevada. This is steel in the ground. This is hardware that we have been building up over the last many months, not a rendering of the systems that we have. There's a danger button on here. What happens? Nothing happens. Oh, there it is. Okay. This in the back, this is our direct air capture module in the far scene. Over here, you can see part of our mineralization system, and then we have bulk bags of reactive feedstock that we are going to be using to durably sequester the CO2 that we're removing via the DAC process. Worth noting, this of course could work with any source of CO2, not just atmospheric CO2 on the mineralization side. The direct air capture system is fully electric, with a nameplate capacity of 100 tons per year. And to highlight this specifically, not only is the direct air capture system carbon negative, but it's water positive. It generates water via that carbonate to bicarbonate reaction. What do I have on the next slide? This one, cool. So a little bit of more information on the DAC side, right? So we use our current novel Gen 1 sorbent, our alkali carbonate composite sorbent, to generate a concentrated stream of CO2, which can be utilized or sequestered in a range of different ways. Our mineralization process takes that DAC source CO2 to react with alkaline feedstocks, again, a range of different feedstocks, and this can durably sequester that CO2 for that 1,000+ year durability. What do you do with those carbonated materials? Anything that you do with any other carbonated materials. They can be sold back into the value chain in construction, aggregate concrete, or other use cases. You can also use alkaline waste as a feedstock in this for waste remediation. In our DAC process, we actively blow air with a fan across the sorbent cartridges that we have, and we have a overhead gantry crane, which is automated, will be automated to move our sorbent from the adsorption system into the desorption system, where it is heated to a modest temperature to regenerate and reverse that reaction. As I said, right now the system is fully electric, and so the only thing that we need into this is a big, thick wire. Once we have done that, a low pressure, high concentration CO2 stream will be generated, go into our gas recovery system, where we can then transport that and transfer that into the mineralization system. So here I want to introduce you to what we call Rocky. Rocky is our mineralization reactor, our first and smallest XC2 mineralization system based on extensive lab scale testing, validation, and analysis that we did in Los Angeles in our site. This uses an engineered reactor to durably sequester CO2 in hours, not years. We have tested a range of different feedstocks to understand the kinetics and equilibrium potentials of those. And then there's a number of in situ sensors that allow us to measure the real-time performance and quantify what is happening inside of this system to meet the necessary requirements for independent monitoring, verification, and reporting that is needed for the most rigorous and high-quality credits to be delivered to buyers. The XC2 mineralization process is powerful and flexible. This does not require high purity CO2, which we know can be a challenge for early stage DAC pilots that can be operating intermittently. It does not require high pressure CO2, which is often required for geologic injection, which can reduce energy and cost. It does not require liquid CO2. And we can directly inject low pressure, low purity gaseous CO2 into the mineralization system and quantify the real-time carbonation rates thereof. We can use a range of feedstock materials, meaning that this can be located in a geographic variety of places both in the US and around the world. And mineralization can be scaled appropriately with a DAC system of any size. This is, again, for a 100-ton system. This could be sized for thousands or tens of thousands of tons and potentially be much more economical at the small scale than Class 6 geologic injection at the size that we're talking about. The hardware that you see here, this is under 70 grand in hardware that we put together. The cheapest well that you're going to dig is 10 million bucks, something in that range, if you're lucky. I'm seeing people say more expensive than that. Obviously, there's a scale mismatch, right? You would never dig a well, a $10 million well for 100 tons capacity. But I think this is closer in size to what our pilot's going to look like for the next several years, if we're being honest with ourselves. So there's significant opportunity here for cost savings for early projects and validation of a lot of the key work that we're all doing. What else? Secondary revenue streams. Carbonated materials can generate alternative revenue streams for our projects. And then, of course, there is no regulatory or political risk associated with the XC2 mineralization process. We built this. That is real. It exists. We've run it. We're doing it today. Unlike geologic storage that does have political regulatory risk and even potential technological risk that's not been fully mitigated at scale. And of course, there's regions where geologic storage may not be viable due to subsurface conditions, but feedstock may be available to allow you to deploy an XC2 mineralization system there. What else? So that leads us, right, what do we see? And this has been a common topic of discussion today and yesterday. What are really the key things that are required for us as an industry to start to go down the cost curve? As I see it, getting steel in the ground and delivering real projects is the most important de-risking factor for direct air capture to increase market adoption and to scale. I think the choice of your sorbent or using an alkali carbonate or using an amine, less critical than getting your projects built, permitted, operating, data, and delivering credits to buyers. That is the exact attitude that we take and why we are moving full steam ahead to do whatever is necessary for us to start to meet these requirements. What does this look like for us? So our technology performs best in the US Southwest in dry climates. And so we're working with folks at the Southwest Regional DAC Hub. I know a number of folks have been on calls with the ASU-led group and other partners in the Southwest, as well as dry climates outside the US as well for future projects. An added benefit, Nevada, where our first project is, has the second lowest percentage of arable land in the state. This here, you're like, what the hell is this? This is the solar irradiance map of the US. You take the exact same solar asset, you deploy it in Nevada, and you deploy it in Louisiana. The one in Nevada gets 30% more energy and gives 30% cheaper energy as a result of that. We can get access to cheaper energy in the regions where we choose to deploy, cheaper land, which makes these projects really interesting from a financial perspective for what we're looking to build. Ending, sorry, I'm over time. I would love to chat. I've been chatting with a handful of folks throughout the conference so far, and I'd love to keep the conversations going. If you are a buyer interested in direct air capture credits, as I said, Clarity will have credits, certified credits that are able to be delivered in 2025 and beyond. Please come talk to me. If you are a direct air capture technology or project developer and you see risks in your storage plans, please come talk to me, and we'd love to chat about that. And I don't know if you can read the last one. If you're an investor, if you're interested in supporting the projects that we're talking about, there is tremendous opportunity for growth by projects that are delivering credits and generating revenue. Please come chat, and we'd love to talk through more of what we're doing with our next set of projects outside of Juniper in Nevada. Thank you so much. Here's my email. Keep in mind, Clarity is not spelt like the normal word clarity. We didn't think about that when we chose the company name. So there is a hidden I in there, but definitely really appreciate all the time. I think I went over, so I don't have time for questions, but please come find me later. Thank you so much.